Welcome back to another episode of our Make It Real Fallout Power Armor series. We're attempting to make the world's first fully functioning T60 power armor, and here is what we've managed so far. Throughout the last 5 episodes, we've managed to finish the armor's pneumatic arms, allowing us to curl over 300 pounds, an augmented reality heads-up display helmet with integrated thermal and night vision, a fully self-contained power pack powerful enough to operate the entire suit, and even some crazy mechanical hands, which didn't quite work as well as expected on the first try, but a lot of you guys had really good feedback in the last episode, so we started implementing lots of those upgrades for the hands, including better cables, tensioning, and finger force tuning. Now, you guys might be wondering, wait a sec, isn't this episode 6 the final episode? Yeah, we're gonna need a few more videos to finish this. It turns out building real-life power armor is a bit harder than we thought. However, we are hoping to have this entire project done by end of the year at the latest.
On the plus side, the upper body of the power armor is almost complete, and it's got tons of power. But it's kind of missing a crucial part, the armor. And that's what we're gonna tackle in this episode. We need to design, prototype, and test some real-life armor plating that would allow this suit to stop bullets and become real-life power armor. Which, by the way, you can make your very own because we've finally uploaded all the parts to Thanks, which means if you've got a printer and some filament, you can print your very own power armor. And in an upcoming episode, we're gonna figure out how to support the weight of this entire thing by building powered legs. So make sure to stay tuned for that. But right now, our goal is to make the power armor bullet resistant. We want it to be able to stand up to things like pipe guns, handguns, shotguns, and maybe even some rifles. And as you know, in the game, the power armor is not only bulletproof, but also allows the user to stay fairly mobile while traveling the wasteland. So we need to find a solution that is not only durable, but also relatively thin and light. So let's get started. So for our composite armor, we need to figure out what composites we have left over from the John Wick suit, and figure out what layup we want to do to give us the most bulletproof and lightest build we can.
Let's consult our bulletproof material library. All right, so after we did the John Wick suit, we put all of our findings into this handy dandy material library with all the different materials, the different layups, the orientation, and the approximate armor level for each. The dynemas. So these were actually really good, but they did the handkerchiefing that you mentioned. But if we have the combination of hard Nanovate and this, it could be good. So again, 25 layers, which gives you 5.4 kilograms per meter squared, which really isn't that much.
In this case, compared to the John Wick suit, we don't necessarily care about the flexibility because the armor is going to be rigid anyway. What we care more about is the weight. And we don't really care about backface deformation because we have that backplate of Nanovate coated armor as well. So we just want the thinnest and the lightest material possible.
And the minimum, we got down to 2.6, but again, not guaranteed. Level 3A, 5.8 kilograms. We've got Kevlar XP K520 and the core matrix. And we saw the core matrix.
Yep. So I'm thinking that this is probably our winner right now. That right there is enough to stop some pretty high caliber rounds. So like if we're curving some of these pieces around my arm,
yep,
that should be quite good.
So this is the stuff that we used for the jacket, but I want to go double check the library to make sure this wasn't the heavy stuff, because I think it might be. We should get the area calculation from the model.
Yeah, I can do that. So we have a couple of test samples. We've got our abdominal plate, of which we're going to take this section area here and use that as our test sample because that's one of the more flat pieces that's going to be easier for us to repair effectively. In terms of area, 36.7 by...
All right, good news. We do have the material that you liked. The Kevlar XP K520. Potentially, we might want to look at armoring certain parts of the power armor with full level 3A. And other parts with less.
I got some calculations for you.
Yeah?
So I threw together a little Excel sheet. So we're roughly around 3,400, which is about 2.2 square meters.
It's not bad. So quite literally, if we went with this for everything, that would only be 12 kilograms to make it bulletproof, not to mention the metal, which will make it more bulletproof.
So we still don't know what material we're going to use for the 3D prints, right? So I've got a couple samples here. We've got these, which are solid nylon, and these are hefty. These, like...
It's probably already half a kilogram by itself.
A piece of solid PLA. Like, that feels like a...
It will be interesting to see how much 3D printed plastic will stop a bullet. All right, let's make some samples.
Let's make some samples. For the samples, this piece should be more than enough, right? What's actually really cool is our Bamboo Lab H2D can actually do laser cutting, and it's perfect for prototyping. But since we have to make hundreds of samples, I'm going to take advantage of the larger CO2 laser that we have. We need 105 pieces, and that's going to make us 18 different samples of different thicknesses and different combinations. And then we need to cut more, and then we cut more of a different one, and then more of a different one still. We have a lot of samples to make. All right, now we've got this huge stack of Kevlar swatches. Just hold them together. We have our first few swatches of the K520. This is 5 layers, and we're going to install them into our 3D printed parts. There we go, our very first test sample. I have to make 17 more. Thankfully, we have over 30 Bamboo Lab printers all around the shop, so we've got a bunch of prints going on. We've got lightweight Aero PLA, standard PLA, and high-strength glass fiber nylon. And with the help of our brand new Bamboo Lab H2D, we now have a massive print bed with 2 nozzles, allowing us to print dozens of samples in multiple different materials all in one go. So while that prints, I'm going to make some metal samples. And even though making the entire suit out of stainless would be way too heavy, we decided to make a few samples to compare against anyway.
All right, so we're here at Urban Tactical, and we're going to test our composite armor for the Power Armor project.
We've got multiple samples of monolithic plastics, Kevlar composites, and even steel to see which one's going to stop a bullet best.
All right, Bogdan, you're up first. Don't miss. Ooh. Did you hit each one?
I think so. I hope so.
Let's take a look. See if this comes off. Bogdan?
Oh, yeah. So the Aero PLA, all 3 went through. You can see that there's 100% Aero PLA, did nothing. But the nylon and the regular PLA at 100% did actually stop it. Good to know.
All right, exact same samples, but now we're shooting it with a 45 ACP handgun. Oh boy.
Nice shot!
Woo! If you average them all out, they're center. All right, it went straight through pretty well everything, except for the 100%. Good to know though. Glass fiber nylon's pretty strong. All right, shotgun slug from 20 yards. Oh! Miss. I'm next. No pressure.
Safety's off.
Okay. I missed. Damn it! There we go. Dead center on that one. Oh, I was close on the second one. Oh, I was really low on the first one. My eyesight's bad. Woo. Nice. And this is why my assistant is my second, and possibly first, if someone duels me.
I broke the stand.
All right, the glass fiber nylon, even in the thickest section, is...
Did it survive? No, it came out here.
Oh.
You're definitely gonna need something a little stronger than this to stop shotgun slugs.
Maybe the composite. Now we got the composites. So we've got different layups of Kevlar.
So these 2 were level 3A, these were level 2 as light as we can go, and these are properly level 2.
All right, so hypothetically, all of them should stop this. Dun, dun, dun.
All of them stopped?
Yeah!
Which means we need to go up to the next round.
Oh, oh!
Wow. Those are not the results that I was expecting.
Where do we start? Well,
That's the core matrix, which in fact held the bullet. What I think we've learned is that how we mount the Kevlar is more important than the thickness of the Kevlar that we use, because if we don't mount it properly, our mount just get blown to shreds, and then that's not bulletproof anymore. If you were to take a second round into that, that would be a bad day for you.
so this is where the Nanovate could really help us, because having a hard layer on the outside makes the bullet shrapnel and the energy dissipates like that. when you're taking all the energy into the piece of armor, that's why it explodes and falls off the target.
We need to pull this one out.
Oh yeah, that's holding it in.
Got it.
Bogdan.
Yeah?
It stopped the bullet.
It stopped them, but you'd still break ribs.
Well, that's where the Nanovate comes in play.
Yeah. Ooh, hang on.
Wait, the Kevlar's inside?
Kevlar's back here, bro.
What the heck? It's on the wall.
All right. Yeah, defending against a slug is no laughing matter. All right, we got some pretty cool results. The composites are definitely faring pretty good. I bet with the coating of Nanovate, we'd actually be like up there in like really good armor.
It seems like the Kevlar is actually stopping most of the rounds. It's actually the fixturing of the Kevlar and how that absorbs the energy that makes the big difference.
But for a point of reference, we're doing a full metal test. We've got 1/16 stainless, 1/8 stainless, and 3/4 inch AR500, which will stop whatever. I don't even know why we're shooting this, because it's going to stop everything. Anyway, shooting metal is dangerous, especially indoors, so we actually have this really awesome gun containment unit. This should lock in and hit the same spot every time. Let's see what happens. 3, 2, 1. Woo! Ho, 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 ho! Look at that dent. Wow. Oh, it stopped it, and your weld's held.
Nice.
So it's still probably not realistic to do the entire power armor out of 1/16 stainless, because it would still weigh, what?
350 pounds?
350 pounds just in metal, not including the exoskeleton, the engine, the batteries, the high pressure system, everything. But based on this, maybe like 1 millimeter of Nanovate or 0.5 millimeter Nanovate might stand a chance, because it's way stronger than stainless steel, which means you need less of it. All right, let's put the 1/8 in.
1/8 stainless. Guess 12 gauge slug.
3, 2, 1. Oh no! Woo-hoo!
My weld did not hold.
So that's the thing, because it's such a small area of metal that's welded on there, it moved out of the way. Like the metal itself didn't fail, the welds failed.
This is AR500 plate, which is what's used in actual rifle round armor protectors and targets for rifle shooting.
So this one should look like nothing happens at all. 3, 2, 1. Woo-hoo!
That's a thud.
Whoa, look at all the lead in the air. Wow. Wow.
Not only did it stop the slug, it literally didn't even get scratched.
I mean, you can kind of see the lead on the surface, but that's about it. But that would be way too heavy to do the entire armor out of this. Lots of interesting results. We're gonna tabulate all of this, and then we're gonna figure out the next set of tests, because we wanna add some Nanovate, or as I like to call it, real-life adamantium to the mix. We might
I think
actually
we've got
have
a pretty
some real
strong
power
armor on our hands.
We've got our armor pieces back from Integrin, so we've got Nanovate in armor form.
Ooh.
So, we've made more samples, like our previous samples, to do the baseline testing for different thicknesses of Nanovate. But once we get all the baseline data, we need to actually make our final composite layup. The reason we got this in a more standard armor plate is we want to compare our composites to just normal body armor, because that's the whole point. We're trying to make this power armor better than what's out there.
Like the 250 micrometer,
Feels solid.
it feels solid. It feels like just metal, but it's light. It's so light for the size of that plate.
So yeah, just to reiterate, these are for our baseline tests. So we have, I think, 1 millimeter thick, 0.5 millimeter, and 1/4. So we'll do the same tests that we already did. And then based on that data, we're gonna make our new composite out of these armor plates, selections of Kevlar and Dyneema, and then we'll be able to test these. And now we should be able to go beyond the 12 gauge slug, beyond the 45 ACP, move to some rifle rounds, and see how strong this stuff is. But there's even more. We wanted to add extra layers of Nanovate in between the layers of Kevlar. So they actually gave us thin layers of Nanovate just as a sheet metal, but formed in their way, which creates the nanostructure, which makes it super strong. Can a layer of this help save your life? It's finally ready. After dozens of design revisions, prototyping parts in-house and abroad, we have the final Smith blade and we're releasing it super soon. It's a 21-in-1 titanium EDC multi-tool with an M390 blade that only weighs 88 grams. It's so light you won't even notice you're carrying it. Tried, tested, proven. It'll be the most useful thing in your pocket. Now the reason we haven't released it yet, or even taken pre-orders, is because when we launch it, we wanted to have a product in hand for our very first customers, and we want it to be perfect. When we launched the Mini Saber Gen 2, it took us almost 8 months before we shipped the product to you guys, and we really don't want that happening again. Since we're moving towards inventing and selling more products, your customer experience is super important, and we don't ever want to lose your trust. As part of that, we've actually decided to manufacture as many of these in-house as we can, which puts us in direct control of manufacturing and makes it possible for us to respond fast, make changes, and even come out with new products much faster, all while making them right here in Canada. But it's going to take some time to ramp up. We've already tentatively ordered some CNC machines we need to build mass quantities of these knives, and we're going to be launching on Kickstarter this summer in order to actually buy the machines and start manufacturing. The number of machines depends on how successful the campaign is, but rest assured, we have Smithblade lights in stock right now, and we will have Founders Editions available immediately to our first backers. So if you want to be one of the first people in the world to experience the world's best EDC, make sure you sign up for email updates at hacksmith.store, linked below. You'll get early access to Kickstarter, and you'll be able to lock in your purchase as soon as it's available. I really can't wait for you guys to get your hands on this. It feels like fulfilling a prophecy as old as the Hacksmith brand itself, from way back in 2013. I mean, the logo is literally a Swiss Army knife on an anvil. All right, so we're back at the range, and now we're going to do our baseline tests against Nanovate. We've got a 0.25 thickness layer and a 1 mil thickness, but it's actually twice that because the back of the material is also coated. We're gonna see what kind of bullets these can stop, and then based on that knowledge and everything that we did last time, we're gonna be able to make our own composites, which will perform even better. All right, so we got some bigger guns this time for our new tests. 12 gauge shotgun, 7.62, 300 blackout, 5.56, and then the 45 ACP. First test, 0.25 millimeter thick Nanovate on a 3D printed piece of the armor against a 45 ACP. 3, 2, 1. No, it fell off. We knew that. It took damage, but nothing at the other side.
Awesome.
That's 1/4 millimeter.
We actually saved weight and were able to stop it.
All right, let's move up the slug. I'm really curious if 0.25 is gonna survive. All right, let's see what happens. 3, 2, 1.
Just the sound of the shotgun is
We
so much
knock over
more.
the thing. Uh-oh.
I see pieces.
Still went through a lot.
Yeah, I don't think a 1/4 millimeter of Nanovate stopping a slug. At least not without any additional Kevlar.
Well, let's see if 1 mil can do anything. I think it stands a chance, but I don't know fully.
If the 1 millimeter stops it, this will be our first slug that we caught with anything other than a pure sheet of air 500.
2, 1.
Hey, there it is.
Well, considering the wadding made it through as well.
Look how thick that layer of Nanovate is too.
Yeah.
And it didn't break on the layer lines or anything. It just fully split between. Ah, that's hot.
A little bit thicker probably would have stopped it.
To be fair, I'd rather
still
be
absorb.
standing behind that than behind nothing.
Yeah. All right, next up, 3D printed stainless steel thanks to our new metal 3D printer, the Meltio. Ignore the print quality on this one. We tried printing it hollow, but this is still pretty thick, so I think it's still going to stop the 45. So we'll see. Yep. 3, 2, 1, go! I see some lead splatter. Or I bent it back because there was nothing supporting it, but that is pretty sweet. All right, let's move up the slug. See if this can stop it. If it can, 3D printed stainless steel. 3, 2, 1. It did it! Move over Nanovate, our 3D printer.
Wow.
And look at that.
Whoa. Just instantly.
Damn.
So, as it turns out, a piece made of 100% weld is stronger than a welded piece. A gun that's quite popular and one of the most iconic calibers is the 7.62, which is known as the AK round, but we can't have AKs here in Canada, but we do have an SKS.
All right, 25% linear infill versus an AK-47.
An AK-47 round.
Close enough. All right, the first real bullet. If this stops it, it's exciting. 3, 2, 1.
I don't know, I feel like I can hear the bullet penetrating through the armor plate.
The bullet penetrated the armor.
Unsurprising to no one.
All right, should we roll it back to the 5.56? See if the NATO round can be stopped. This is a 5.56, so it's about 300 joules less energy than a 7.62, but it is a smaller bullet, which means it might just punch right through. 3, 2, 1. I think we blew up another light.
3 for 3.
Maybe looking good. Looking not so good. Rifle rounds are hard to stop. Who knew? All right, so for the last monolithic tests, Integrin hooked us up with some pure Nanovate foil. This is formed perfectly compared to coating on the 3D printed parts. All right, can we fold this into 3 maybe? Stepping on nanotechnology.
Who wants to take bets on if this thin of a sheet of foil can stop 45 ACP?
Let's stop talking about it, let's start shooting. 1. Do I see a bullet? Wait.
Did we?
Almost. What a cool crack propagation. It formed an X. It went through, but that is really cool. So this is 6 layers of 0.2, so that's 1.2 millimeters thick. But that's still not very thick. 3, 2, 1. I like the sound of that. You know, yeah, I feel like even just like a single layer of Kevlar could make all the difference with that. Look at that, the Smith blade cuts Kevlar like no problem.
This is the kind of stuff you see in Fallout. Just scrap metal with scrap fabric.
If this works at all, then our composites stand a chance of being pretty awesome.
Oh yeah.
3, 2, 1. We caught it. It broke all the Nanovate, but we caught it. Okay, the last layer stopped it. So the Nanovate is definitely like, I want that as my last line of defense.
The first layer of Kevlar stop it?
No, sorry, the second layer.
Okay. But I do think that the energy absorption of the Nanovate breaking behind it definitely helped the Kevlar not deform as much and absorb more of that energy.
Exciting. We now have enough information from all these monolithic tests that we can make a spreadsheet of all the different materials we've tested, the Nanovate, the stainless steel, the Kevlar, the different types of plastic that we 3D printed the parts out of, and we can come up with our own composite that we can then fabricate the power armor out of. And the hope for the power armor is, at the bare minimum, 22-45 slug, but hopefully we can make heavy armor that can stop some rifle rounds.
So we've had a lot of successful testing, but the question still remains, what's the best composite? So we're going to be using these armor plates to test that. We've got a few different thicknesses of Nanovate, we've got a various layups of Kevlar, and this is going to allow us to compare to real body armor. So I've got to make a bunch of these, and then we're going to get to the range. All right, anyway, that's going to take some time. Let's get back to the grind.
You're still playing Fallout?
Yeah, I mean, I like to call it research, but of course I'm still playing Fallout. They literally just released the new update of the ghouls, and I'm trying to get to that point. You know, it also helps me figure out what kind of features I want to add to the armor. Ah, there's ghouls! There's ghouls! What is this guy? Ah! You didn't see that. I definitely didn't just miss an entire mag. Now that we got the Kevlar all cut, we gotta cut the Nanovate pieces. Come take a look. Here we got a beautiful sheet. This one is 0.1 millimeters thick of Nanovate. It's got a mirror finish, and we're going to use them as the back plates. Woo! Shiny. Does this look like armor? Like, would you believe me if I told you this can stop a bullet?
So we're back at Urban Tactical, and we've got our new composites that Bogdan chose based on the data from our last tests. Bogdan's brought some light armor, medium, heavy, and super heavy. We're pretty confident that light will stop everything that we've previously tested because we're using elements of everything that has succeeded. If it does survive, the question is how much more can it take? Which is why we then have the medium, the heavy, and this, the super heavy, which we're hoping can stop a really big gun.
The Nanovate is really, really great at stripping full metal jacket off of bullets, and it's really good at preventing backface deformation. Layered with Kevlar, hopefully the Kevlar will be able to absorb that energy and then distribute that into the Nanovate, which can then, you know, prevent the bullet from going through. This thing is super light. We've had a hard time stopping shotgun slugs, and this is pretty much the thinnest of everything we've had thrown together.
Apes alone, weak. Apes together, strong.
I hope so, fingers crossed.
3, 2, 1. Definitely fell over.
I think it caught it. Like, that would still hurt, but if that was on your abdomen, you'd break a few ribs, but it'd keep you alive. Man, I'm excited. I cannot believe that stopped a shotgun slug. It didn't pierce a single layer of Kevlar.
All right, medium versus blackout.
All right.
It's gonna go through.
Can we stop a rifle round with...
Dun, dun, dun. I was right.
Right through?
So do we just go straight to the heavy?
The theory was that that'll stop a rifle round.
3, 2, 1.
Can you see it? It didn't stop it?
Oh, sorry, I lied. Yeah!
You asked.
Woo! Look at that nubbin. What we were kind of hoping of, like, Nanovate foil could be a really great last line of defense.
Yes.
So there's no fibers going into you. That's not much deformation at all. So 762.
Same piece of armor. Can this take 2 rounds? Let's see. 3, 2, 1.
You know what? I'm gonna let you go behind there and check.
It went through. What we're learning is
Steel core rounds, armor piercing.
hard to stop.
So would you like to put a hole in your super heavy?
These are super heavy. Is our last line of defense. The only thing that may or may not stop an AK round. And this is pretty much the last of the Kevlar that we have. It's the only option we have. Super heavy versus AK full metal jacket.
Uh-oh.
All right, James.
Big sad. We didn't magically make better armor than the armor industry has been making for years? We can shoot a level 3 and see if it stops it. All right, level 3 body armor plate. Whoa, it came back out. Whoa. It's almost like armor manufacturers know what they're doing.
So this plate is lighter and stronger than the one we've made. So we've done a lot of testing. Our super heavy did not stop a AK round. But the thing is, we could never wear super heavy as it is anyway. The suit would have still been like 600 to 800 pounds if we were to do this. So the exciting thing with our light armor is that our light armor was able to stop a 12 gauge slug. And that makes this pretty much level 3A armor for very, very little weight. And at the end of the day, that's what we want. We want the suit to be able to take Raider weapon, a pipe gun. This would stop. And we've also proved that with a bit of armoring, our heavy was able to stop a rifle round, the blackout. We know that we have a couple of different options, and we know that Kevlar is definitely going to be the best option by weight for stopping bullets, but the Nanovate is going to give us a lot of extra ability to break that bullet apart and make a nice hard coating that's going to last a while.
It'll still be the world's most durable power armor suit.
Yes. And then in the vital areas, such as your chest, we're going to be able to
might just use real
actual body armor because
there's
at the end
room.
of the day, there's people out there that have developed this stuff over years and years and years and put millions of dollars into researching and development, and our armor still outperforms ours in certain ways. Okay, so I've gone ahead and recorded all of our data and compiled the final results. So for a start, let's talk about the Kevlar, which proved to be a clear winner in terms of strength to weight ratio. You see, it only took 4 layers of Kevlar to stop a 22 long rifle. And for the 45 ACP, that only went up by 50% to 6 layers. For an additional 60% or 10 layers, we were able to stop a 12 gauge slug. But then, for the 300 blackout round, that number of theoretical Kevlar layers jumps all the way up to 46 layers, or 460% more Kevlar. This really puts into perspective just how much more piercing power the rifle rounds carry. But that's not the whole story. While Kevlar is a clear winner in terms of strength to weight ratio, and I could stack up 100 layers of Kevlar to stop any bullet caliber, that would only weigh 320 pounds. However, it would be about 2 inches thick, and that would make the suit look more like the Michelin Man than it would the Fallout power armor. But how does that compare to the Nanovate? Well, each quarter millimeter of Nanovate is roughly equivalent to a Kevlar layer, and initially the data looks quite similar. That is, until you put them side by side, and immediately you can tell just how much thinner the Nanovate ends up being. But that's not the whole story. If instead of comparing by layer thickness, we compare by layer weight, the Kevlar is still significantly lighter. So our magic composite lies somewhere in between. So let's throw the test results on an actual graph and compare other options. On the y-axis, we're comparing the thickness in millimeters, and on the x, we're referencing the weight in grams. The different calibers are represented by the size of the dot, and the closer we are to the bottom left, the better. And immediately we start seeing a few outliers. The PLA and glass fiber become ridiculously thick in order to stop the rifle calibers, about 220 millimeters or 8.6 inches. And that would be solid infill, which would weigh over 4 kilograms or 8.8 pounds for just a small swatch. Similarly, the stainless remains quite thin, but the weight quickly adds up. This small abdomen piece would end up weighing over 4.8 kilograms or 10.6 pounds just to protect your abdomen, which would make the entire suit over 2,000 pounds. Completely unacceptable. So let's zoom into the graph to see the more realistic options. Here we can see our Kevlar, and with quite a steep slope, that shows that the thickness increases rapidly with more layers. Lower to the bottom, with a much flatter slope, is our AR-500, Nanovate, and stainless. And while they're a lot thinner, they're also much heavier. The Nanovate shows really promising results, as its added density over the AR-500 means it can be even thinner for the same stopping power. So our magic composite should lie somewhere in between these two slopes. But where? So I've gone ahead and added 2 more trend lines, one for the light armor and one for the heavy armor, which were able to stop the shotgun slug and the 300 blackout round respectively. And as you can see, they border closer to the Nanovate line, which means that we could make them lighter. If we optimize the split bullet energy, that yields us this pink line over here, which is a little bit better. But if we were to optimize for weight allocation, meaning we allocate 1 gram of Kevlar per gram of Nanovate, that yields us the cyan line over here. And this would maximize the bullet energy absorption of the Kevlar while providing the benefits of stiffness and bullet breakup capacity of the Nanovate. Which means we'd end up using the same Kevlar composition as our heavy armor and the Nanovate coating from our light armor, giving us a medium armor weight with heavy armor stopping capabilities. Perfect for our T60 power armor. But what's next? Well, obviously we have to 3D print all of the parts, laser cut and install all the Kevlar, and then have everything nanovated, which is going to take quite some time. So in the meantime, I've been working on doing the leg design, which is really cool, and I'm excited to get working on that. But we've also finished up the power pack and are getting ready to get that installed with a bunch of upgraded electronics and software. So if you're interested in that, make sure to stay tuned for the next Power Armor episode.